Student, kalian dapat absen dulu ya. Lihat di chatnya, sudah ada nggak link untuk absen?
Baik, dokter. Saat ini link absennya belum ada di chat, dok.
Bentar ya, mau dikirimkan sama Mas Madan ya.
Baik,
Baik,
dokter.
dokter. Sudah ada link absennya ya di chat atau nanti absen masing-masing. Absennya akan dibuka sampai pukul 12 ya, setelah itu ditutup ya.
Baik, dokter.
Saya harap nanti ada pertanyaan ya. Sebisanya, nggak masalah kok. Oke, dengan bahasa Inggris santai aja ya. Mas Madan, mungkin bisa di-sharekan lagu Marsnya FK, biar nggak membosankan.
Baik, Dok. Fakultas Kedokteran Universitas Mula Warman adalah sekolah kedokteran yang terdapat pada Universitas Mula Warman di Samarinda, Kalimantan Timur. Kampus utamanya terletak di Gunung Kelua. Kampus ini berdiri sejak tahun 2001 sebagai program pendidikan dokter. Sejak 1 Juli 2004 program pendidikan dokter naik statusnya menjadi program studi kedokteran umum dan akhirnya menjadi Fakultas Kedokteran sejak 7 Mei 2008. Pada awal pendirian dipimpin oleh Dr. Latif Foibar Caropeboka, SP.Pd. Ketua PPD, 2001 hingga 2006. Kemudian dilanjutkan Dr. Emil Bahtiar Murad, SP.P. sebagai Ketua Program Studi Kedokteran Umum, 2006 hingga 2008. Lalu menjadi Dekan FK Unmul, 2008 hingga 2016. Kemudian dilanjutkan dengan Dr. Ika Fikriah, M.Kes, Dekan 2016 hingga 2020 dan 2020 hingga 2024. Visi Fakultas Kedokteran Universitas Mula Warman adalah menjadi fakultas kedokteran berstandar internasional yang unggul di tingkat nasional dalam pengembangan pendidikan, penelitian, pengabdian masyarakat di bidang kedokteran dan kesehatan yang bertumpu pada hutan tropis lembab, tropical rainforest, dan lingkungannya pada tahun 2034. Selain itu, fakultas juga memiliki rumah sakit pendidikan di RSUD Abdul Wahab Syahrani, tempat pendidikan lain meliputi RSJD Atma Husada Mahakam untuk pendidikan kesehatan jiwa, RSUD Dr. Kanujoso Jatiwibowo Balikpapan, RSUD Aji Muhammad Parikesit Tenggarong, Rumah Sakit Abdul Muiz, Rumah Sakit Mata dan juga Puskesmas di Kota Samarinda untuk pendidikan ilmu kesehatan masyarakat. Fakultas Kedokteran Universitas Mula Warman memiliki 9 program studi. Program studi kedokteran, program studi profesi dokter, program studi kedokteran gigi, program studi pendidikan profesi dokter gigi, program studi D3 keperawatan, program studi spesialis ilmu bedah, program studi spesialis pulmonologi dan kedokteran respirasi, program studi S1 keperawatan, program studi profesi nurse. Kegiatan mahasiswa, beberapa kegiatan mahasiswa yang ada di Fakultas Kedokteran Universitas Mula Warman. Fakultas Kedokteran Universitas Mula Warman didukung dengan pengajar yang sangat profesional. Fakultas Kedokteran Universitas Mula Warman didukung oleh fasilitas yang memadai. Tentunya kami terus belajar dan meningkatkan kemampuan dalam mencetak lulusan terbaik di masa depan. Kerjasama dengan perguruan tinggi di Indonesia. Dengan rumah sakit di Samarinda. Dengan pemerintah pusat. Dengan pemerintah daerah. Dengan perguruan tinggi di Kaltim. Kerjasama luar negeri. Maastricht University, Belanda. Erasmus University, Belanda. Universiti Kebangsaan Malaysia, UKM. Universiti Teknologi Mara, UITM, Malaysia. University of Hong Kong, Hakau. Dengan bangga kami mengajak Anda untuk menjelajahi keindahan kampus yang bertumpu pada hutan tropis lembab tropical rainforest dan lingkungannya serta nikmati pengalaman berharga dari kampus kedokteran yang berstandar internasional dalam pengembangan, pendidikan, penelitian dan pengabdian masyarakat. Fakultas Kedokteran Universitas Mula Warman adalah sekolah kedokteran yang terdapat pada Universitas Mula Warman di Samarinda, Kalimantan Timur. Kampus utamanya terletak di Gunung Kelua. Kampus ini berdiri sejak tahun 2001 sebagai program pendidikan dokter. Sejak 1 Juli 2004 program pendidikan dokter naik statusnya menjadi program studi kedokteran umum dan akhirnya menjadi Fakultas Kedokteran sejak 7 Mei 2008. Pada awal pendirian dipimpin oleh Dr. Latif Foibar Caropeboka, SP.Pd. Ketua PPD, 2001 hingga 2006. Kemudian dilanjutkan Dr. Emil Bahtiar Murad, SP.P. sebagai Ketua Program Studi Kedokteran Umum, 2006 hingga 2008. Lalu menjadi Dekan FK Unmul, 2008 hingga 2016. Kemudian dilanjutkan dengan Dr. Ika Fikriah, M.Kes, Dekan 2016 hingga 2020 dan 2020 hingga 2024. Visi Fakultas Kedokteran Universitas Mula Warman adalah menjadi fakultas kedokteran berstandar internasional yang unggul di tingkat nasional dalam pengembangan pendidikan, penelitian, pengabdian masyarakat di bidang kedokteran dan kesehatan yang bertumpu pada hutan tropis lembab, tropical rainforest, dan lingkungannya pada tahun 2034. Selain itu, fakultas juga memiliki rumah sakit pendidikan di RSUD Abdul Wahab Syahrani, tempat pendidikan lain meliputi RSJD Atma Husada Mahakam untuk pendidikan kesehatan jiwa, RSUD Dr. Kanujoso Jatiwibowo Balikpapan, RSUD Aji Muhammad Parikesit Tenggarong, Rumah Sakit Abdul Muiz, Rumah Sakit Mata dan juga Puskesmas di Kota Samarinda untuk pendidikan ilmu kesehatan masyarakat. Fakultas Kedokteran Universitas Mula Warman memiliki 9 program studi. Program Studi Kedokteran, Program Studi Profesi Dokter, Program Studi Kedokteran Gigi, Program Studi Pendidikan Profesi Dokter Gigi, Program Studi D3 Keperawatan, Program Studi Spesialis Ilmu Bedah, Program Studi Spesialis Pulmonologi dan Kedokteran Respirasi, Program Studi S1 Keperawatan, Program Studi Profesi Nurse. Kegiatan mahasiswa, beberapa kegiatan mahasiswa yang ada di Fakultas Kedokteran Universitas Mula Warman. Fakultas Kedokteran Universitas Mula Warman didukung dengan pengajar yang sangat profesional. Fakultas Kedokteran Universitas Mula Warman didukung oleh fasilitas yang memadai. Tentunya kami terus belajar dan meningkatkan kemampuan dalam mencetak lulusan terbaik di masa depan. Kerjasama dengan perguruan tinggi di Indonesia. Dengan rumah sakit di Samarinda. Dengan pemerintah pusat. Dengan pemerintah daerah. Dengan perguruan tinggi di Kaltim. Kerjasama luar negeri. Maastricht University, Belanda. Erasmus University, Belanda. Universiti Kebangsaan Malaysia, UKM. Universiti Teknologi Mara, UITM, Malaysia. University of Hong Kong, HKU. Dengan bangga kami mengajak Anda untuk menjelajahi keindahan kampus yang bertumpu pada hutan tropis lembab tropical rainforest dan lingkungannya serta nikmati pengalaman berharga dari kampus kedokteran yang berstandar internasional dalam pengembangan, pendidikan, penelitian dan pengabdian masyarakat. Fakultas Kedokteran Universitas Mula Warman adalah sekolah kedokteran yang terdapat pada Universitas Mula Warman di Samarinda, Kalimantan Timur. Kampus utamanya terletak di Gunung Kelua. Kampus ini berdiri sejak tahun 2001 sebagai program pendidikan dokter. Sejak 1 Juli 2004 program pendidikan dokter naik statusnya menjadi program studi kedokteran umum dan akhirnya menjadi Fakultas Kedokteran sejak 7 Mei 2008. Pada awal pendirian dipimpin oleh Dr. Latif Foibar Caropeboka, SP.Pd. Ketua PPD, 2001 hingga 2006. Kemudian dilanjutkan Dr. Emil Bahtiar Murad, SP.P. sebagai Ketua Program Studi Kedokteran Umum, 2006 hingga 2008. Lalu menjadi Dekan FK Unmul, 2008 hingga 2016. Kemudian dilanjutkan dengan Dr. Ika Fikriah, M.Kes, Dekan 2016 hingga 2020 dan 2020 hingga 2024. Visi Fakultas Kedokteran Universitas Mula Warman adalah menjadi fakultas kedokteran berstandar internasional yang unggul di tingkat nasional dalam pengembangan pendidikan, penelitian, pengabdian masyarakat di bidang kedokteran dan kesehatan yang bertumpu pada hutan tropis lembab, tropical rainforest, dan lingkungannya pada tahun 2034. Selain itu, fakultas juga memiliki rumah sakit pendidikan di RSUD Abdul Wahab Syahrani, tempat pendidikan lain meliputi RSJD Atma Husada Mahakam untuk pendidikan kesehatan jiwa, RSUD Dr. Kanujoso Jatiwibowo Balikpapan, RSUD Aji Muhammad Parikesit Tenggarong, Rumah Sakit Abdul Muiz, Rumah Sakit Mata dan juga Puskesmas di Kota Samarinda untuk pendidikan ilmu kesehatan masyarakat. Fakultas Kedokteran Universitas Mula Warman memiliki 9 program studi. Program Studi Kedokteran, Program Studi Profesi Dokter, Program Studi Kedokteran Gigi, Program Studi Pendidikan Profesi Dokter Gigi, Program Studi D3 Keperawatan, Program Studi Spesialis Ilmu Bedah, Program Studi Spesialis Pulmonologi dan Kedokteran Respirasi, Program Studi S1 Keperawatan, Program Studi Profesi Nurse. Kegiatan mahasiswa, beberapa kegiatan mahasiswa yang ada di Fakultas Kedokteran Universitas Mula Warman. Fakultas Kedokteran Universitas Mula Warman didukung dengan pengajar yang sangat profesional. Fakultas Kedokteran Universitas Mula Warman didukung oleh fasilitas yang memadai. Tentunya kami terus belajar dan meningkatkan kemampuan dalam mencetak lulusan terbaik di masa depan. Kerjasama dengan perguruan tinggi di Indonesia. Dengan rumah sakit di Samarinda, dengan pemerintah pusat, dengan pemerintah daerah, dengan perguruan tinggi di Kaltim, kerjasama luar negeri, Maastricht University, Belanda, Erasmus University, Belanda, Universiti Kebangsaan Malaysia, UKM, Universiti Teknologi Mara, UITM, Malaysia, University of Hong Kong, HKU. Dengan bangga kami mengajak Anda untuk menjelajahi keindahan kampus yang bertumpu pada hutan tropis lembab tropical rainforest dan lingkungannya serta nikmati pengalaman berharga dari kampus kedokteran yang berstandar internasional dalam pengembangan, pendidikan, penelitian, dan pengabdian masyarakat.
wait Professor Sun from Taiwan.
Niat ciptakan karya, tulus mengabdi wujudkan cita. Janji profesi terpati di hati, teguhkan langkah membangun negeri. Fakultas Kedokteran Mulawarman, unggul cerdaskan bangsa yang beriman dan bertakwa. Fakultas Kedokteran Mulawarman, unggul di hutan tropis Kalimantan. Luhur Rahayu Indonesia sehat. Fakultas Kedokteran Mulawarman, kebanggaan Murieta.
Morning, everybody. We wait Professor Sun from Taiwan. Please wait.
Menjadi saksinya saya begitu besarnya cinta dan rasa sayang orang tua kepada anak-anaknya. Lalu kita berikan pelukan dan juga ciuman kepada ibunda tercinta. Boleh Kak Ejat dicium untuk ibunya. Boleh berikan pelukan, ciuman kepada
punya
Good morning, Professor Sun.
Yeah, good morning, Professor Sylvia.
Do you hear my voice? Good sound, Professor.
Yes, I hear your voice. Okay.
Okay, we will begin the presentation today. So good morning, student, colleagues, and Professor Sun. Today we have the pleasure of hearing a presentation from Professor Sun with the title The Yesterday, Today, and Tomorrow of Digital Dentistry from the Taipei Medical University in the Department of Dental Technology. Professor Sun is an expert in the dental material, manufacturing, and digital dentistry, including 3D, 4D, and 5D printing, as well as dental robotics. It is truly a honor to us to have him share this knowledge with us today. Before we begin, let's take a group photo with Mr. Ramadan coordinating the session. Okay, Mr. Ramadan, time is yours. Can you bring the sign if you are ready to take the picture?
Oke, mohon diaktifkan kameranya ya.
Everybody open your camera.
Mohon diaktifkan kameranya. Baik, akan saya aba-aba. Untuk slide pertama, 1, 2, 3. Kemudian untuk slide kedua,
Thank
1,
you.
2, 3.
Finish, Mr. Ramadan.
Selanjutnya, 1, 2, 3.
Are you finished, Mr. Ramadan?
Page 4, 1, 2, 3. Page untuk slide yang ke-5, 1, 2, 3. Yang terakhir, 1, 2, 3. Finish.
Okay, thank you, Mr. Ramadan. After the photo session, we will move on the Professor Sun presentation, which will be split into 2 sessions. The first session will run from 10:05 to the 11, followed by 15 minutes to break, and then we will continue to the second session from 11:50 to the 11:50. After that, we can take the QA session. Okay, let's begin. Professor Sun, the time is yours.
Okay, thank you very much. Sorry, let me to open my file, okay? Okay, let me share my, okay. Okay, okay, does everyone see my PowerPoint? Professor Sylvia, do you
Yes,
have
I'll
seen?
see the PPT, Professor.
Okay, it's very clear.
About everybody, do you see the PPT?
Yes.
Yes.
Yeah, I do
Okay.
though.
Yes, I see.
Everybody can see your PPT, Professor. You can
Okay, thank you.
continue your presentation.
Professor Sylvia, everyone, good morning. This is my great honor to take a talk for today. The title for my talk is The Yesterday, Today, and the Tomorrow of the Digital Dentistry. I am the Professor Yong Kang Sam. My English name is Kevin. I serve as the School of Dental Technology, College of Oral Medicine in Taipei Medical University. Welcome to my talk. And today I will distinguish 3 topics. Yesterday for the dentistry, today for the digital dentistry, tomorrow for the digital dentistry. And what about yesterday? Because the history is very important in the full world. So if you will focus any topic, you must to know the history. oral history is the yesterday. They ask to talk. This is I will thank so many library. They give me so many photo on here. This is the original about maybe the 1,000 years ago. There are so many people, they have the oral diseases. So maybe sometime, maybe have the dentistry, maybe for himself to treat oral diseases in here. So you can see the oral diseases is the big problem in the whole world. Although this cannot make your body to death, but the pain is very difficult and very trouble in the whole world. And because I know that Indonesia is believe so many Eastern so I use so many allopath for treat oral disease. In the left side, upper suggestion remove size from the patient pocket. In the right side, upper doctor use the protective tube to perform aging and consolidation of the dental block. So you can see here, you know, before or maybe the 1,000 years ago, there are no doctor or no dentistry, just the doctor. But you know, in there are so many dental equipment to treat oral diseases in there. But in the maybe close to the 18th century, the dentistry is divided from the clinic doctors. So the dentistry is a special course for the whole world. Now this is a dentistry taking current or patient with the tooth tech. You know, the oral disease is a very difficult and very trouble problem in the whole world. So there are so many people need the dentistry to do the treat oral diseases. And this is, I will thank the Greece provide me this the original very old equipment. The odontograph is the Greek letters, but now we call it a tooth extraction for scrap. You know, there are so many dentistry use this equipment to treatment the teeth, especially the teeth take off from our mouth. There are so many old. Sorry, there are so many other equipment on here. You can see from left to right side, there are so many equipment in here, especially for any teeth treatment. I will also thank the library to provide me so many photos. And this is the very special. Dr. Morris come from the USA. In 1868, he developed the first dental clinic chair in here. This chair is manufacturing by this chair is manufacturing by the hand, not the machine. So just in 1868, Dr. Morris just manufacturing 4 chairs in that year. So you can see this is the first dental clinic chair on the whole world. I think just maybe 200 years ago. So until now, we have the very fashion dental clinic chair in the dental clinic.
Excuse me, Professor Sun. Can
yes.
you share your next PPT, because we don't only see your title, not see your other PPT. Can you share?
Yeah. What? So anyone do not see any PowerPoint?
No, there are see, but only the title. Can you share the yesterday thread of the oral disease line? We see right now.
Sorry, you're meaning from beginning to talk again?
No, you can continue to talk.
Yeah.
Not from beginning. Okay, you can continue. We only want to see your PPT. Okay. Thank you, Professor Sun.
So does everyone can see my PowerPoint PPT?
Everybody, can you see the PPT?
Yeah,
Yes,
Okay, yes.
Yes, everybody can see it, Professor.
Okay,
okay, you can continue it.
Okay, now I will talk about today. Today, my course focus on the today and the tomorrow. And I think there are so many people, you are the dentistry. How about today's? But in here, you must know, in here, because my school belong to the School of Dental Technology, we asked so many students use the maybe the knife to cutting, to do the tooth covering. This is a traditional skill by hand. So you can see there are thousand, more than 100,000 plasta. We use the hand to cutting the maybe the molar or premolar. This is a traditional scheme by hand. But now, if the dental technician will help the dentistry to do the teeth, but we must change the skill in today. So next, now we call it a digital oral engineering, DOE. This name is for myself to debug in a forward. So if you have any interest, please remember the digital oral engineering. This is very special because why? So impression, there are so many dentistry in the left side. This is the dental impression. This is the dental impression taking about I think about
Professor Sen,
yes.
Sorry, can you running your PPT because we not see the next PPT? Can you running?
I have run in the PPT, so cannot see.
No, we can. Yeah, we see right now.
So also I use this. Okay.
Okay, thank you.
So everyone, sorry, maybe I will talk about for here. Okay. Traditional skill by hand, because I serve as the dental technology. Our student use the hand, use the knife to cut in the molar or premolar for plasta, and this is the traditional skill by hand. But now, you know, by hand is wasted too many times. So now we use the digital oral engineering. So you must know, this thing is developed by myself. Digital oral engineering, we call it not just including the dentistry. You know, we have the 3 topics in the College of Oral Medicine: dentistry, dental technology, and the oral hygiene. So I combine together in here. I talk about this is the digital oral engineering, can develop 3 kind of people in the College of Oral Medicine. So about maybe about 10 years ago or 20 years ago, the dentistry also use the dental impression technique. You can see in here, this is the all time. Use the maybe this is the plastic material. This is the plastic material put inside the patient mouth, and they close the mouth and maybe keep the 10 seconds, and finally let the patient open the mouth and to take off this impression. But what about this is very has some problem, because if you use this dental impression technique, you must ask the patient, their mouth maybe move sometimes, maybe the precision maybe will be worse. But now you know, this is the old time. Now we use the oral scanner, maybe the 3D shape or the other equipment. In here, this picture, you can see the dentistry use the oral scanner to scan the mouth or teeth on the patient mouth. So this is this time. I think in Taiwan, 95% dental clinic now use the oral scan for to take the patient teeth data. We have give up the dental impression taking. So maybe now is the digital dentistry time. Maybe I don't know in Indonesia how many percentage for the oral scanner, but in Taiwan, we use the over 95 percentage for the oral scan. So now has the big problem. Oral scan is the easy skill, but you know we have the 62 teeth in our mouth. But if you scanner for a mouse, each teeth has the so many delta, total 32 teeth. You need so many delta. So how to save and how to merge the one by one teeth, the delta is very difficult. So our our engineering and the dental technology student also want to learn how to write a program and use the software to combine and merge the data from the scanner data. This is very important because our teeth is the curve surface. Curve surface, that meaning for the mathematical model, z is equal to fxy. That meaning is the curve surface. This is the mathematical model. That as the z is equal to ax plus by plus c. This is the curve surface model. That is must merge this model to write a program to merge the oral scan data. And now there are two kind methods for the digital oral engineering. The first is the forward engineering. The second is the reverse engineering. I must say the digital oral engineering comes from the engineering topic because in our medicine and the dentistry, we apply so many topic and the method from the engineering. So there are two kinds for forward engineering and the reverse engineering. Now I will one by one to talk about the forward engineering and the reverse engineering. The first, I will talk about the forward engineering. Sorry, I drink the water. There are three kinds for forward engineering. The first is the computer-aided design. We call it a CAD. The second is computer-aided engineering. We call it a CAE. The third is computer-aided manufacturing. We call it a CAM. Now I one by one to talk about this. Computer-aided design, that is use the software to plot your body part. That as in the right side, I plot the ear for the computer-aided design software. So how about briefly for the computer-aided design? You can plot any part, any engineering, any body part. So you can get an original database in here. In Taipei Medical University, we use the SolidWorks as the software of computer-aided design. For myself, I teach the SolidWorks in the Taipei Medical University. We can use this software to plot anything, like as the car, airplane, ear, nose, molar, premolar, canine, and so on. So, but if you want to use the computer-aided design, you must to learn the skill because there are so many icons in the computer-aided design software. So in the Taipei Medical University, we must waste 18 weeks. We must waste 18 weeks to learn the computer-aided design. But when you finish this course, you can use the software for the computer-aided design to plot anything. So I raise a ear model in here. After we use the computer-aided design to plot any part, you must know that as in our teeth, put on our mouth, every time we eat anything, maybe the breakfast, dinner, or lunch, we must know the stress or strain for our teeth and for our muscle. So we must use the computer-aided engineering. We call it a CAE to analyze maybe the force. Also, you can analyze the temperature for the model for the computer-aided design. In the Taipei Medical University, we use the ANSYS and the MOVE to do the analysis for the computer-aided design part. So we call this skill is the computer-aided engineer. But this is very special. If we want to use the software, you must know the theory. The theory comes from the two topics. In the later, I will talk about that. The first is the solid mechanics. The second is the fluid mechanics. So maybe sometime I can ask the dentistry student or dentistry professor, you can do the research or something cooperation with the basic professor. Finally, when we use the computer-aided design to plot a part and use the computer-aided engineering to analyze the part like as the force or strain or temperature. Finally, we can use the computer-aided manufacturing. We call it a CAM to produce the product. In Taipei Medical University, we use the 3D shape, this software and the machine to cutting the tooth in the Taipei Medical University. So let me raise some example for you. This is our use the computer aided design. The software name is the SolidWorks to plot the model. This use the skill to plot the model, not the scanner. So you must know this is the curve service. You must know the so many mathematical modeling or mathematical theory. Otherwise, although you can practice model in here. I think if you learn in the Taipei Medical University over 9 weeks for this course, you can practice model in here. So sometimes why I ask my student not just limited use the auto scanner, also use the computer aided design, because you can use the computer aided design, plot the model, you also can plot the muscle, also can plot the hand or eye or nose. To sum up, you can plot anything in here. The first, when we use the computer aided design CAD to plot this teeth on here, we must do the computer aided engineering. I call it a computer aided engineering CAE. Because today I talk about so many dentistry, so I focus on dentistry theory. The first, you must know the solid mechanics. The software is ANSYS. The second, you must know the fluid mechanics. The software is the Morpho software. Sorry, maybe let me to talk what is the solid mechanics. If you want to do the research or if you want to take an advanced skill for the dentistry, you must know the solid mechanics. There are very special solid mechanics theory. We call it the mechanics of material. Especially the first important is the Young's modulus. Young's modulus meaning the stress over strain. The second is the fluid mechanics. You know, in our human body, the blood is the liquid, the air is the gas. We call these two kind of fluid is the fluid mechanics. And sometimes in our mouth, maybe sometimes you use the hand piece to do the oral disease. Maybe sometimes water or gas we are put into on the patient mouth. So you also must know the fluid mechanics on here. Now I raise an example that you know how to use the computer aided engineering to simulate the mechanics and for the stress and the strain in our teeth. This is the finite element analysis model. In the left side, this diagram you see, this is this is also plotted by the computer aided design software. So we in here you can see there's so many models on here. This is a cancerous bone. The implant is sitting inside the cancerous bone. This is an abutment. This is an artificial ceramic teeth. And everyone must know artificial ceramic teeth. The material is ceramic. Abutment and implant, the material is titanium alloy. I enlarge this model in here, so you can see the very clear in here. When we use the computer aided design to plot the artificial teeth, abutment implant, and the cancerous bone, in here, we use the computer aided engineering to do the analysis on here. Now, in here, you can see, please see the right side. I made a kinetic force is equal to 500 Newton in here. Maybe this is the judging for our teeth. This is the artificial teeth. This is the implant inside the cancerous bones. In here, we can get a deformation. The deformation meaning the deformation meaning the part is the some by bending or something has the shape change. You can see in here the red color, that is the meaning in here has the maximal deformation. The color going to the blue, the deformation is small. So in here you can see if we use the 500 Newton for the judging force in our teeth, you can see in here, because this is the model, in here we have the maximal deformation on here, and inside into the implant, you can see that so many deformation has the different value for deformation on here. Finally, we must know the stress. What is the stress? stress meaning is force over area. So in also we use the 500 Newton as the creates force in here. Please see here. This is artificial teeth. This is a cancerous force. This is the apartment. You can see the apartment has the maximum stress in here. The red color meaning the higher stress. The blue color meaning lower stress. For our simulation, for the computer-aided engineering, you can see in here the apartment has appeared the maximum stress. So in the future, or the company must enhance the apartment in here. Otherwise, maybe in the future, if the patient use the implant over 5 or 10 years, maybe sometime the material broken will appear on here. We enlarge this region in here. Please see in here. This is the bone. This region is bone. This region is implant. You can see for the implant and contact for here, the red color and the blue, yellow color. This region has a maximum stress on here. So if our titanium alloy, the hardness is larger than the bone, maybe sometime in here, because in here has the maximum stress, we will make the bone may be broken. If you use the titanium alloy, the hardness is lower than your bone, maybe the implant will be broken in here. So this point is the weak point for the implant or our bone. This is very important because you cannot do the experiment on the patient mouse, but you can use the computer and the aided engineering in here, and let our human or our dentistry must be noticed on this point. And finally, we divided the implant and the abutment. You can see in here is the abutment, in here is implant. So because the abutment lacked implant on here, so you can see because orange, you can see this is the weak point. So also the abutment in here has the maximum stress on here. So this is the weakness. I must say, maybe you do not know why about this, but I just tell you, if you use the digital oral engineering, you can use the simulation, not do the experiment, can get the maximum stress on here. Finally, if you are the dentistry or maybe you open the implant company, you must notice in this place. Otherwise, maybe in the future, over 5 years or 10 years, maybe implant in here, maybe we are cause the crack. This is the mold flow for the analysis. You can see in here we have the false teeth, and in here we use the ceramic inside in here and fill up this false teeth. In here, in one time we can make the ceramic artificial teeth, maybe just 10 seconds. But this is very difficult for the engineering. So today I just show you this mold flow analysis. In the Taipei Medical University or in the Japan or in the American Indiana University, traditional ski by hand also has the course. But if one, I must tell to you, if we want to use the training our student to cutting the very good motor in this type, I think the student must waste 2 years. Why? Because sometimes the feeding for the dental technician, their hand, and sometimes not just the your hand feeding, and also you must your brain to know that, and so many times you also must know the margin line and so on. So this is very difficult for training the hand because the student also have the other course. So sometimes in Taipei Medical University, we will find maybe the training 2 years can plot a very good motor by hand on here. I think the schedule and the time is too long. And now in Taipei Medical University, when we use the computer-aided design and the computer-aided engineering, and to get so many database, we can use the computer-aided manufacturing. We call it a CAM. Use the machine to do the tooth crown. In here, this is the titanium alloy plate. we use the computer aided manufacturing. This is the cutting machine to cutting the tooth crown on here. Also, we can arrange this plate is the circle. Maybe in this region we can get more than 30 or 40 tooth crown in here. But in here, this is the tool. So the tool material is very hard. Maybe the SiC or all the other material. The tools is very expensive, and they use this tool to cutting the surface for the titanium alloy. Computer aided manufacturing, the benefit is if you use this machine to cutting the tooth crown, you can very easy and quickly to get a tooth crown. But the other leg off is this machine is very expensive. In Taiwan, this machine may be the $1 million Taiwan dollars, $1 million Taiwan dollars, and you know the tools cutting the titanium alloy maybe the 3 months later or 6 months later, maybe the tools maybe you must change the tools because the tools age, maybe the sometime may be broken or cause so many problems. So the tool also must waste so much money. So use machine is very good, but if you want to use the machine to do the tooth crown or the implant, you must waste so many money. But the computer aided manufacturing definitely is the automatic. You just use the database put on the machine. Everything you do not care. You can let the machine work more than 24 hours. You just, when the machine finish the work, you just take this plate out of the machine. You can get so many tooth crown on here. And if your database is correct, you just use the machine to do everything. You do not use the waste 2 years to do the training for the tooth covering by hand. But also, if you want to use this machine, maybe you must have the training. I think in Taipei Medical University, our students more than 3 months training, they can use this machine very easily. And this is our traditional, we call it forward engineering. But now, because sometimes we use so many oral scanner or micro CT or dental CT to get so many database. We have the other method can do the to get a same procedure. I call it a reverse engineering. Reverse engineering, the first you must the scanner. The scanner may be the oral scanner, CT, MRI, or PET. This is I raise an example for the CT image. I will thank the Taipei Medical University provide me the dental CT for here. If you use dental CT or oral scanner to scan our mouth, you can get an input file. The file name is DICOM. DICOM cannot use. You must use the transfer software, Miro and Aroma. Miro and Aroma will transfer the DICOM, transfer the STL. You know, STL file is the this file can use on the computer aided manufacturing and also use on the 3D printing machine. So this output is very efficient. So if you can get an STL, I will ask today I will ask today listener. You must know the STL file. This file is very important. If you get an STL file, you can let a computer aided manufacturing to cutting the tools or use the 3D printing machine to print the model for here. In here, I raise an example. For dental model, you know, the Japanese company Nissan, they made so many good dental model on here. This is the Nissan dental model I21D 400Z in here. I put this model to our hospital dental CT. In Taipei Medical University, we have a dental CT. The name is the dental combine. We put on here, you can see we scan the Nissan model, we can get a DICOM file on here, DICOM file on here. I think the resolution is very good. And in here, we use the mimic. This is a transfer software can transfer this scanner or DICOM to the STL file. And if you get this STL file, you can put on the computer aided manufacturing to cutting the crown or put on the 3D printing to get the real product on here. But the other way, because in Taipei Medical University, sometimes we will change the file. So we use the Reynolds. Reynolds is the very famous design software in the whole world. If we use the Reynolds, we can transfer the STL to the 3DM file. If we can get a 3DM file, we can change the database for the teeth or the other things. So maybe we just get a fixed file for the STL on here. We can change the database for the Reynolds, can get a pointer 3DM, can get a real data and the other data change. So this is the, I must tell you, this is belong, let me to see, this is the reverse engineering. For the scanner, for the transport software, finally, we can get a STL file. And when we get here, in this, maybe in this 3 years or in past 20 years, 3D or 4D printing is the very famous on the whole world. Let me talk about the 3D and 4D printing on here. There are two kinds of printing in here. The first is the traditional. The second is the bioprinting. Traditional 3D or 4D printing. This is the EOS machine on here, and we use the material is the metal, polymer, and the ceramic. The other is the 3D or 4D bioprinting. Bioprinting, we had has a different because of the fire. This machine is the original type for Imperial College in the United Kingdom. They use the cell and the hydrogen and so on as the material to print the product. But if you use the bioprinting, you can print the tissue or organ immediately. If you use the traditional 3D or 4D printing, you just print the maybe the product. But if you want to print the cell and the hydrogen, you must do the cell culture or the animal test. Now, I will talk about the 3D printing for everyone. Mr. Jack Hall studied a bachelor degree in the Massachusetts Institute of Technology in USA. He has something. He know traditional, we use the cutting or use the knife to cutting the tools. Why we can use the machine to produce the 3D product. So in 1984, when he graduated from the MIT, Massachusetts Institute of Technology, he opened a company for the 3D system. Because in MIT studied a bachelor degree, he developed the original type for the 3D printing machine. So in 1984, he developed the first company for the 3D printing. The company name is 3D System. I must tell you, there are 3 names for 3D printing. About 1984, we call the 3D printing is the adhesion manufacturing. We call it AM. About 20 years ago, the name changed to the rapid prototyping, RP. About 10 years ago, we call it 3D printing. These 3 names also the focus on the same situation. There are so many, when 1984, the Chuck Hall developed a 3D printing machine and opened a company. Until now, there are so many types on here. The first type is the SLA, 3DP, and the SLS, SLM, and the FDM. Let me one by one to introduce. In the left side, this is the SLA. This is the first development by the Chuck Hall. That means Chuck Hall developed the SLA. What is the SLA? You must know the name. Stereolithography apparatus. We call it a SLA. Please see this diagram. In this can, we fill up the liquid photopolymer. This is the photopolymer. We use the laser. We use a laser projection on the liquid photopolymer. If the liquid photopolymer mean the laser because laser has the energy. the liquid will become to solid. And how to control this scanner system? Also, we use the maybe the auto scanner or computer-aided design to get a STL file. This STL file, we are cutting the piece, one piece by one piece, and get the software and the controllers laser. So one piece and one piece projection on the surface of the liquid photopolymer. When the liquid photopolymer mean the laser, because of energy made the liquid become to the solid. And this platform will down forward one layer, and the liquid photopolymer will emerge on the surface of the solid, and the laser then to projection another time. So one layer and one layer we can get in here. Finally, we can get a 3 product in here. So you must know for the SLA, you must have the laser, you must have the liquid photopolymer. How can compatible for the this material and laser? So you must, if you change this polymer, maybe you want to change the laser, because the laser energy will influence the liquid photopolymer, because each polymer has the different molecular chain. The molecular chain will influence the laser energy. So you cannot use one laser to use on the different kind photopolymer. So you must have the compatibility for the laser and the material. And in the flow work, what kind of the SLA for the company? 3D system, immersion TEC. The second 3D printer machine is the 3DP. 3DP, that is our laser printer. But you know the laser printer just print the paper is the 2 dimension. In here, we print the 3 dimension. That is, in here, we also have the powder put on the plate. And we use the inkjet printer to print the powder in one by one layer, one layer. That is the one paper, and the platform will downward to print the other paper, and the one paper and the other paper with the adhesion together. So this is the 3D printer. We call it the 3DP. The polymer, the inkjet polymer is the inkjet material is the polymer. The company is the 3D system, ESO1, and the voltage deck. And now, if you want to use the tools material or implant, SLS and SLN is very suitable for the dentistry. What is the SLS? Static laser sintering. In here, we put on the metal or ceramic powder on the platform, and we use the laser, maybe the CO2 laser, to project on here. You know, the high energy made a powder, ceramic or metal, powder and powder diffusion on together. And one layer and one layer will produce the 3 product on here. But what is the sintering? Because if you use the 3D printer SLS to print the 3 part, this is just the green part. You must do the heat treatment, because if you use the heat treatment, can make the product strength very enhance their strength. So SLS sintering is that's meaning. We use the metal or ceramic powder for SLS. The company is EOS 3D System Archon AB. The other type is the SLM, static laser metering. The equipment all the same, but the process is if you use the CO2 laser, make the powder diffusion on together, because the high energy will make the powder may be the metal or ceramic to maybe the surface diffusion, and then combine together. This is melting. Also, for the static laser melting, you also must do the heat treatment. Otherwise, the stress is not enough. The material used the metal and ceramic. The company is the EOS 3D System and Archon AB. I think SLA, 3DP, SLS, and the SLM, this 4 kind machine is very expensive. So about 10 years ago, field decomposing modeling, FDM, used on the floor work. This is the machine. The machine used this is the heater. This is the polymer fin, and connect to the printer the polymer street, the polymer street is the solid. When put on this heater, this head is the heater, and then the polymer becomes soft, and put on the printer for one layer and one by one layer. So because this equipment is very easy, you can see the 3D diagram here. So FDM fused decomposing modeling is for of the forward because this machine is the equipment is very easy and the price is very low. So I think in Taiwan, even senior high school, we have the FDM to use, maybe to print the maybe the toy and so on. So if you use the FDM, the polymer is their material. But now has the very special FDM because you can use in right side, this is the one material. And in the left side, you can see the red color and the blue color. Sometimes the FDM can deposition the two different material on the same time. So FDM is the very good good machine. Use the different material on the same time to produce the 3D product. There are so many companies develop the FDM like as the Stratus, Ramp, Big from Byte. Now I will show you how about we use the 3D printing machine to use on the Taipei Medical University. Please see the right side. You know, I don't know in the Indonesia, do you have this machine? This is the FORMLAB, FORMLAB. And about this price for this machine, about maybe the 400,000 Taiwan dollars in the Taiwan. The FORMLAB, the machine type is the SLA, stereo lithography apparatus. So in here, you put on the liquid photopolymer on here and use the laser to project on its surface. So in Taipei Medical University, you can see we can produce the different teeth on one time. This is the 28 different kind teeth. We can make one time to produce. I think we wasted 6 hours to do this to produce the 28 teeth on the same time. So you can see if you want to use the hand or use the computer-aided manufacturing to produce these different 28 teeth, you must waste so many time. But in the TMU, we just waste 6 hours we can get here. Because SLA also use the polymer, so you can see here, we get the teeth or use the polymer material. And maybe sometimes we just to do the model and to training the student how to use the 3D printing machine. If you want to use on the patient, maybe you must use the SLS and the SLM to produce the real ceramic teeth. But the method is the method is very similar. Just use the different kind for the machine. The other way, we use the FDM in the Taipei Medical University. You can see this is my lab 3D printing machine. The type is the FDM. You can see we can produce the molar on here. I think the precision is very good. And for the training, you can see in this side we use FDM to produce the 101 building on here. Maybe I enlarge the 101 building to you. You can see we can provide a very clear and very high precision and high resolution for the 101 building. So in here, you know, you can use the 3D printing machine to manufacturing everything. In here, we use the SLA and the FDM to produce the real product on here. And maybe sometime, Professor Sylvia, because I just said yesterday and today, does anyone has any question for my talk? Does anyone
do you have a question, Professor Sun?
Yes, because I finished talk yesterday and today. Does anyone has the question?
Okay, if you don't have a question, I have a question, Professor.
Yes.
It's
Yes.
about the ANSYS software. ANSYS software.
ANSYS.
Yeah, that's right. So what is the difference between the ANSYS software and the OpenFOAM? Because I'm using OpenFOAM. What is
Yes.
the difference?
Okay. Let me show everyone of this this familiar stress. There are so many computer-aided engineering software, CAEs or software in the full world. But why we use the ANSYS? Because ANSYS is the most popular in the full world, and the ANSYS maybe occupy the analysis for the full world about 70%. So sometimes like as the dentistry, maybe you buy the handpiece, use maybe some company, because this company handpiece occupy the more percentage in the full world. So the answer is the first. The answer occupy the analysis about over 75% on the full world. The second, because answers they have the main powerful for the analysis, like as I say, the solid mechanics and the fluid mechanics. And this company has more than 10,000 people to develop this software. So they develop more and more powerful for the ANSYS can do so many medicine and dentistry analysis. That as you can use the ANSYS to calculate the blood tube, the blood inside the blood tube for the pressure. And we can use the ANSYS to simulate in this style, this slider for the stress for the implant and the bone. So the other software also can get a very similar result, but I think ANSYS has the great powerful because today, if sometime I have the other time, I will tell about for you the computer-aided engineering. Because if you want to use the computer-aided engineering software to calculate the stress or the strength for the teeth or implant, you must have a powerful material database. Like as the implant for the titanium, you must know the Young's modulus, heat conductivity, and the density, and so on. So you must have the power database library in this software. But we know the ANSYS software has the very maximum or very powerful database library in their software. So this is why the ANSYS can analysis on the whole world. This is my answer. Thank you.
Okay. So you think that ANSYS is good than the OpenFOAM? That's right,
Yes.
Professor?
And the ANSYS has some identified by the so many dentistry papers and so many dentistry clinic case. That meaning we use the ANSYS software can compare the experiment or animal test or IRB with the ANSYS result, get the same result. So ANSYS has identified for the FDA in USA. So if you use the ANSYS to calculate any case, the FDA in USA will identify your case is good and your case is correct. If you use the other software, you must know how about this software can identify for the USA FDA identify.
Okay, thank you, Professor. Student, do you have a question? Student, do you have a question? No. If you don't have we don't have a question again to the Professor Sun, so we close for this session. We take a break 50 minutes, so we'll back around 11:10. That's right, Professor?
Okay, 11:10. Okay,
Okay.
11:10. Thank you. Thank you very much. Okay. So we'll take a break now, okay?
Student, I hope you have a question for the Professor Sun, because this material is very interesting.
Okay, Professor Sylvia, so we now take a break, okay?
Yeah, we take a break right now, Professor.
Thank you very much. Thank you.
Okay.
阿佑，你知道我在干什么吗？对，他们印尼牙医师上课。用那个档案，就是用 notebook 印尼的牙医是200 student， 对吧？印尼的 dentistry， 你可以看，没关系。
Sebaiknya ada pertanyaan ya. Nggak apa-apa kalau grammarnya nggak bagus atau kurang ini nggak masalah. Prof ngerti kok itu. Student,
Iya dok.
Iya dok.
tanya aja, nggak masalah. Ini memang materialnya soal 3D printing, ada chip manufacture sih. Saya sih mau mengajar ini, tapi kita kan belum punya alatnya masalahnya ya. Jadi agak bingung nanti kalau untuk menjelaskan tanpa mempraktekannya. Ya, tapi bisa aja ditanya ya. Karena kan saya sudah menyentil masalah CAD cam ya. Ini juga membahas masalah CAD cam. Oke, bertanya aja ya, Dek ya. Nggak apa-apa kok ya. Oke.
Baik
Nanti
dok.
kita kembali untuk sesi yang berikutnya jam 11.10 ya.
牙医，我明年要到印尼，我明年要去，他们有学校要我去演讲。苏门答腊，哎，我忘了是加卡达还是我忘了是 Java 还是苏门答腊。印尼好热。对啊，印尼很热，我去过两次，一次到苏拉威西，一次到苏拉威西的马卡萨，另外一个叫Java 的意思就是苏拉巴雅。苏拉巴雅，I go to the two city，一次到马卡萨，一次到苏拉巴雅。
Student, Can you return to your laptop because we will start a new session?
Yes, doctor.
Professor Sun. Professor. Professor Sun, are you ready for the second session? Professor Sun,
Yes,
are you ready?
I'm ready.
Okay, for the time for the second session between 10:50 to the 10:50 because we want to give the 10 minutes for the Q&A. Okay, the time is your professor. You
Thank
can
you,
continue
thank you,
class.
Professor Sylvia. Good morning, ladies and gentlemen. I think the second topic for tomorrow of the digital dentistry, maybe will let you very feel difficult because, but I try to take it very easy to everyone. How about tomorrow for digital dentistry? We must talk about the artificial intelligence. Artificial intelligence, we call it AI. I must tell you the history. About in 1970, also in MIT, Massachusetts Institute of Technology. In this university, some professor, we call it Mokola, he want to find how can the people can use the mathematics to do the everything for the maybe the machine or the other things. So they also use so many things for the artificial intelligence. Because in MIT they also must learn so many mathematics and write a program for simulation. So artificial intelligence, the first developed in the MIT in the USA. After the 1970, the artificial intelligence just begin announcements in the whole world. Until now, you know, this century and these 5 years, you must know artificial intelligence. Today, I will just talk about the artificial intelligence, how to apply to the dental clinic, digital dentistry, and how to use on the dental technology. So today, I will talk you produce tooth crown through dental technology is the best function of dentistry because our dental technician will help the dentistry to manufacture so many tooth crown. But traditional tooth crown are mainly produced by hand covering. The morphology of the tooth crown is the most important parameter for evaluating its acceptability. So I think there are so many dentistry you always to listen to some word morphology, maybe the teeth morphology. This is the very important for the dentistry, dental technology, and the oral hygiene. But it is necessary to make a high quality shape. Shaping a tooth crown is often relating the training and the experience, both of which are time consuming. So you know, if you want to make a good tooth crown, you maybe use by hand, maybe by 3D printing, maybe use by the computer aided manufacturing. You must use so many training time. And now this 5 years, we go into the AI year. So maybe we can use the AI to training in here. Digital dental technology, I just talked about section 1 in today. Processes are affecting the oral industry. The price of the computer-aided design, computer-aided manufacturing, we call it the CAD, CAM, three-dimensional printing, 3D printing, and the digital color meters and the oral scanner to dental technology has gravity changed all of the traditional dental technology and the manufacturing process. But nowadays, apply artificial intelligence in various fields is very popular, and the impact on the medical industry are fully developed. In view of the inverse application of artificial intelligence in the dental technology field, this talk will emphasize on the use of machine learning of the artificial intelligence to determine the quality of the morphology of the tooth crown in order to rapidly obtain uniform and excellent crowns. Maybe I will talk about details. I know also the dentistry, maybe sometimes you use your hand to cutting the tooth morphology, maybe the molar or premolar. And in the dental technology, we also training the student use the knife to cutting the plaster to maybe to training the morphology for the molar or premolar. But now have some big problem. If if the student just beginning to learn how to cutting or how to manufacturing the morphology of tooth of the tooth, they did not know maybe the first molar. They did not know when they finish the job. They did not know how about this job is good or false. So the student must ask the teachers, maybe the dentistry, maybe the dental technology teacher, ask the teacher how about my cutting for the first molar, the morphology is good or false. So we must use we must let the student teachers waste so many time to teach and to how to let the student to make a good morphology. Our idea in the Taipei Medical University, my idea, can we use the AI to train you and to AI have some database when you cutting your tooth crown? Maybe that AI may add as the judgment to replace the teachers to tell you your manufacturing tooth crown is good or false. This is our traditional thinking. So the introduction. Human teeth are the subject to damage and loss due to accident, today, decay, old age, and oral disease. As a result, dental restoration are one of the most prevalent dental techs. To repair tooth damage or remove a tooth require making a tooth, which was traditional carried out by dental technician by hand. This required repeated practice to accumulate experience, but the various people might have different options as to the quality of the tooth. So the first step is making a tooth is that the tooth morphology must be correct and aesthetic pleasing. Therefore, in this talk, we use the machine learning ML of the artificial intelligence AI to evaluate the tooth morphology. So this diagram for the engineering use direction classify. I also will apply to the section 1. You see the engineering, there are two kinds, FE and the RE. FE is the forward engineering. RE is the reverse engineering. For the FE, forward reverse engineering, use the CAD, CAE, CAM. Finally, use the CNC to cut in the tooth. Okay. The other way, maybe we cut in the CNC, use the mold. Original, maybe the 1,000 years ago, we made a mold and use the casting, molding, forging to make a metal crown in the full world. Finally, we get a real product. The other way, engineering, the other step is the reverse engineering. We call it the RE. Use the scanner, get a file, transfer the file, and use the CNC or 3D printing to print the product. If you use the CNC, go to this here and to follow this way. If you use the 3D printing to print the real product. But until now, the procedure of this talk are divided 4 steps. Tooth correction, scanner skill, use the mathematical method and the software, and finally, calculation of the machine learning. Maybe the student you do not know here, but today section 2 just that you have the concept of artificial intelligence. You are the dentistry, start use scanner the teeth and get a morphology, use the mathematical software, use the machine learning to judgment the twist crown good or false. If yes, ending this procedure. If no, repeat again, use the scanner, check for morphology, use the mathematical software to, and finally use the machine learning to double check your tooth crown. And now I raised the example for the dental technology in the Taipei Medical University. Now I will talk about the method. The first, we must correction the teeth. Ladies and gentlemen, this is a part of dental prosthetic case. We use the FDI 16 to correct. In our university, we training the dentistry and the dental technology student to cutting the prostate maybe so many times. So we have a large amount for the tooth covering. So that this is the FDI 16. So we can correction these teeth, maybe the more than, in this case, we take more than 345 teeth in our class and put this class, put all the, this case. We do the second scanner and the filtering. So we use the scanner. This is the desktop auto scanner, desktop, not a hand scanner. That desktop auto scanner, we use this machine is manufactured by the Korea. We scan the tooth morphology one by one. I think you scan more and more is very good because we get a big delta on here. So we scan field correction by desktop scanner on here and get so many delta in here. And then we will do the delta processing because we scan more than 345 pieces on here. So plus the raw after scanner and the scanner are arranged by the mesh matrix software. You just know this software. You can just use this software. You do not, maybe you do not know the theory, no problem. Use the mesh mixer software to one by one to check each plaster rod. And now we do the delta processing. You can see this is the arterial teeth FDI 46 front view. This is the prosthetic FDI 16 top view. We use the face tone capture software, capture fixed size of the different teeth. In our case, we can do the so many that as the premolar or molar one by one, get the delta base for the scanner and the file. We do the delta processing in here. We can get so many delta base on here. And now, because in our training, we must have a reference group. We buy the, this model is the C726T4 46 for the, maybe the Nissan company. This is the front view, this is top view. This is the, maybe we could call it the STEM model. That meaning the morphology is excellent for this model. We use a model and to comparison the student cutting model. And finally, we use the AI to training. The method for the machine learning, maybe this shape, this 6 step, maybe make you difficult, no problem. I just get you some idea. For the machine learning, when we get this 4 step, you see we collection the teeth and the scanning and filtering, delta processing, different model, and for the reference group as the reference. Finally, we use the machine learning. There are 6 steps on here. The first, set goal. What do you want to the machine to learn and what is your purpose? The second step is the database construction. The training machine need to have the sufficient amount of the data, very clear and simple. I think the data more and more is excellent. The 3 step, selecting feature of the judgment. According to your goal, selecting the image that you want to machine to use this as the main judgment for training. The 4th step is the model selection. According to hardware equipment you have, the complexity of the property, and the time permit, you can choose the depth of model. Deeper and more complex does not always mean better result. The 5th step is the training. Repeat the training based on your training result until you are satisfied with your result. Finally, the 6th step is evaluate the model. Let the model perform some actual compact test to evaluate whether it is really feasible, and if not, go back and restart. Now I will talk about your result and the discussion on TMU, how we use the AI to let the student can use the AI to judge their cutting tools. Now from here, I think this is very difficult because AI concept come from the mathematical. So maybe you know some mathematical. If you do not know this, no problem. I just give you the concept. If you want to use the machine learning to judgment your morphology of the teeth, you must know the mathematics. The first is the computer matrix. Find the computer matrix because if any product that as the morphology of the tooth, we have the actual value and the predicted value. The actual value has the positive and the negative. Predicted value also the positive and the negative. So this is actually positive and predicted positive. We call it a TP, and it is FP, FN, TN. Where TP, FP, FN, TN are the number of the true positive. The truth class is the positive example, and the predicted class is the positive example. False positive, the truth class is the negative example, and the predicted class is the positive example. So you must have you just remember, actual value has the positive and negative. Predicted value has the positive and the negative. So for the arrangement, there are 4 kinds on here. The false negative is the truth class is positive and the predicted class is negative. True negative, true technique, we call it the TN in here. The true class is the negative example, and the predicted class is the negative example. Respectively and confounding to the related importance of the precision value recall, and is usually set up 1. The second is the precision. Precision is the P. Precision is the TP over TP plus FP. TP, FP, FN, TN on here. So precision is the TP over TP plus FP. What is the precision? The precision rate is also called a precision rate, which is the prediction result, and it's meaning the probability of the actual positive sample among all the predicted samples. The second is recall. Recall is equal to TP over TP plus FN. The recall, also known as the real recall rate, is for the original sample, and its meaning is the probability of the being predicted as a positive sample, and is an actual positive sample. The recall is also called a true positive rate, TPR. Now, false positive rate, FPR. FPR is equal to FP over FP plus TN. Number of negative sample results predict to be the positive and the actual number of the negative samples. The F1 value is equal to 2 multiplier precision multiplier recall over precision plus recall. That is meaning 2 multiplier TP over 2 multiplier TP plus FP plus FN. Find a balance between precision and the recall. That is, it considers both precision and the recall. Let the two reach over the highest of the same time and the balance. And the micro average and the macro average. Micro average, P micro is the TP over TP plus FP. That meaning is the sigma I is equal to 1 to N TPI over sigma I is equal to N to I equal to 1 to N TPI plus sigma I is equal to 1 to N FPI. So I must tell you, if we want to learn the AI, especially machine learning, I must focus on the mathematics. R micro is equal to TP over TP plus FN. is equal to sigma I is equal to 1 to n TPI over sigma I is equal to 1 to n TPI plus sigma I is equal to 1 to n FNI. Finally, F micro is equal to 2 multiplier P macro multiplier R micro over P micro plus R micro. Micro average is to express a global computing matrix for each instant in the delta set, regardless of category, and then calculate the corresponding indicators. The other is the macro average. P macro is the 1 over n sigma I is equal to 1 to n pi. R macro is 1 over n sigma I is equal to 1 to n ri. Finally, F macro is equal to 2 multiplier P macro multiplier R macro over P macro plus R macro. Macro average is the first calculate the status index value of each class, and then calculate the arithmetic mean of all classes. In here, I will let you know how about our training and how use the machine learning. Among all of tools provide delta set, the largest number of the teeth of FDI tooth position 16 was calculated. We used the 342 teeth in total in this talk, and so this tooth was selected to train the prediction model. When we input the new FDI tooth position 16, the picture was transferred to the CNN predict modeling with 4 combination layer. You can see this is the new important tools legend FDI 16. Finally, we use our machine learning to do the training. In here, the horizon is the false positive rate. The vertical is the true position rate. We use the ABC, these 3 model to here. For the A in here, for the A in here, for the B in here, for the C in here. Finally, you see for the C, we get finally we get a true positive value is about 0.68, 0.681. The judgment result obtained whereas following predictor are shown in figure. Result about the AUC was the 0 in here, 0.5 in here, and 0.62. The larger of AUC value, the better of model. Where it is a master that if the author carry a new photo of the carbon tools into this research program, the efficiency will be about 70 to 75 after machine learning calculation, and can correct assess the quality of the tooth morphology. What about the meaning for this diagram? When we use the 342 FDI 16 to training to get a database for the machine learning. So the machine learning correct the 342 database. Finally, he has the good idea for the machine learning. When he put the new FDI 16 in here, we can get finally we can get a 70 to 75. Can let you know how about your new cutting tooth covering is good or false. So we have the 70 or 75 to know your tooth covering is good or false. But I think this value is also too low. Maybe in the future we can get a 90% in here. So when we use the machine learning to training AI, can add us the judgment. When the new tooth covering put the diagram put on here, you can put this photo, just 2 photos, put on the AI machine learning. They can tell you about this tooth morphology over 20 or 27.5 is good or false. Finally, I will tell you to sum up. Similar value can be obtained through calculation and analysis of the 2 different concepts of micro average and the macro average and the AUC. Finally, it is a must that if we bring a new cover tooth photo into the program, the current efficiency of machine learning is about 70% to 75% to correctly assess the pros and the cons of the tooth morphology. So because the COVID-19 over 3 years, our student cannot go to the university to do the tooth covering and let the professor to see is tooth covering good or false. So we use the AI and machine learning. We collection the tools, maybe the first premolar, second premolar, first molar, second molar, and three molar. Collection of so many teeth and put on the machine learning. They training them which one is better, which one is false. And in the last year for the COVID-19, our students, when they finish the tooth covering, they just take two photos. When they just took the two photos like this, maybe the front view and maybe the front view and the top view, and use the mobile phone to take the two photos in here, and finally to put on the machine learning library. The machine library will tell the student maybe the correct is about 70 to 75. Your tooth coverage is satisfied for the professor requirement. If the student cannot get this satisfied, they must repeat their tooth covering again. And finally, the student cannot go to the university. They know their tooth covering for teeth morphology is good or false. This is we use on the COVID-19 the last year for the COVID-19 in the Taipei Medical University. And finally, I will tell about the conclusion for my talking on today. Why we will learn the yesterday, today, and the tomorrow for the digital dentistry. I must let you know the age for the tooth manufacturing. The traditional for the technology, you can see our student, even the dentistry or dental technician, they must use hand to do the tooth covering training to get the morphology for the plaster. So I call it by hand experience and training. By hand experience and training to get a good morphology. But maybe you must waste 2 years. I think the 2 years is very quickly, because everyone, every student, they are feeding for the tooth, the hand, they are feeding for the bread, maybe has a big difference. So sometime in Taipei Medical University, for the hand to do the tooth covering, I have met some student just half year. He or she can do the very good tooth morphology. But I also meet the other student, maybe with 3 years. He also get a worse tooth morphology. So the traditional technician, like as the so many workmen in the full world, like as the cutting, like as the maybe the art, like as the design, like as the building workmen, they must have the hand experience and the training finally to get a good morphology. And this experience maybe cannot very easy to transfer to the next generation, because everyone has his thinking, everyone has the feeling for his hand. But until now, we must use the artificial intelligence. I always in here, maybe I will tell you for the ABC in here. Sorry. So this is my first time to talk about a student. I write a paper for the ABCD. D is the digital dentistry. A is AI, artificial intelligence. B is the big data. C is the cloud. In this time, the AI time, you must know the ABCD. A is artificial intelligence. We call it the AI. B is the big data. C is the cloud. AI, there are so many models that as the machine learning to collection the product and the training finally get a good result. big delta, you must have so many delta. The delta more and more is good. If you have the more delta, you can let the AI to training. Finally, because if you collection the big delta, you must have the bigger or maybe the hard disk. But you know the memory is the waste so much money. So you must put your big data in the cloud. So this time I call you the artificial intelligence, big data, and the cloud. These three kind concept correction to the digital dentistry. So I call it the ABCD. Please repeat my word. A, AI, B, big data, C, cloud, D is digital dentistry. For ABCD, we judgment maybe the tooth covering. Finally, get the well morphology in our university and in our training. And maybe if you do not, if you cannot, if you do this training by the AI, you can save so much time. We also let the AI to help the student in the Taipei Medical University. They can save them so much time because when they when they finish the tooth covering, they can use the AI to judgment this morphology is good or false. And in the future, I will maybe make you so afraid because maybe the AI not use the human to do, use the robot to do. So maybe in the future, deep learning and the AI robot to replace the human, and they can use the robot as the AI concept to do the tooth covering and get an excellent morphology. Why? Because deep learning and the ABCD, the robot has so many ideas. Their brain connect to the cloud. They had so many good morphology in the robot brain. So he do not repeat the false. He every time he cutting the tooth, every time get the correct. So maybe sometimes save so many time for the tooth covering and the tooth morphology. So maybe in the future, deep learning combined the AI robot will help us to do the very good tooth morphology. So I call it the excellent morphology because the experience, because the training all on the ABCD. So maybe the save the time to get a good result in the full world. So finally, I will try to say you again. Traditional technology is the past, maybe it's the yesterday. By hand, experience training for the good morphology. Today, I think the AI has happened in today. So in today, AI, you must know for the artificial intelligence, big data, cloud combined the digital dentistry, we can get a well morphology. Tomorrow in the future, the AI also the AI combine the deep learning and the AI robot. Do not use a human being. You can make an order to the AI robot to do the tooth covering. Finally, you can get an excellent morphology. So in my idea, in human being, you can get a good morphology. In AI help the human being, you can get a well morphology. Finally, if you use the AI and the robot, you can get an excellent morphology in the full world. So in the maybe I also go to the so many university to see the AI. I think not just limited for the school of dentistry, the school of engineering, school of medicine, they always use the AI. But that is the big problem because if you want to use the AI that as the software, maybe sometimes you must know the mathematics. Let me to repeat again in here, that as the confusion matrix. So I think in the future, if you want to use the AI, the mathematics, like as in the university, must recover the mathematical course for maybe the first year or second year student. Just that you have the concept for the mathematical. If you have the concept for the mathematical, you can use the AI software in the website. There are so many AI software and the deep learning. You can know how to use this AI software to help you to do so many work. And if you get a false result, you also know how to repeat training and to get the correct result. This is very important. So I must tell everyone today, you must recover your mathematical learning. Maybe just the senior high school student mathematics, or maybe in Taiwan, we have the first year to learning the calculus. The calculus, the first important for the AI training. So I think maybe from now, the mathematics must let you to use and to learning in any college. I think just maybe the liberal art college do not use the mathematics in medicine, engineering, business, and science also must learn the mathematics. And why we use the learning the mathematics? Because when we finish the mathematical course, we can use the AI concept for the full world. So let me finally to let you see again traditional technology by hand, by experience, by training to get a good morphology. Today, for the AI time, use the ABC, AI, big data, cloud for the judgment to get a well morphology. In the future, tomorrow, you also use the AI, use the deep learning, combine the robot to get the excellent morphology in the full world. So finally, this is my talking, and this is the photo. I go to the elephant, a mountain elephant to take a 101 building. In here, this is the Taipei Medical University campus. And I think this is the good region for the Taipei Medical University to get a nice region for the 101 building. Today I will finish my talk, and I hope everyone can go to Taiwan, and maybe learning and maybe do the research or maybe do the clear case with the Taipei Medical University. Thank you very much. I finish my talk, Professor Sylvia.
Thank you, Professor Sun,
Thank you, Prof.
for your wonderful presentation. Give applause for Professor Sun. And then, are there any questions from the audience? Student, do you have any question? Student? Student, do you have any question?
Can I ask, Professor?
Okay, please.
Okay. First of all, I would like to thank for the professor who gave a lecture about scan and 3D printing for dental, which was very useful and very interesting for all of us. And I would like to thank you for being given the time to ask questions. Okay, let me introduce myself. My name is Muhammad Naufal Ambila, and I am from the class of 2023. Okay, what I want to ask is, are there any challenges or limitations in using oral scans and 3D printing in dentistry? And I would also like to ask about, are there any certain cases or situations where the oral scan and 3D printings cannot be used, and we have to go back using the traditional ways and using traditional impressions material like hydrocolloids or silicones and polysulfate and the other else. That's all I want to ask. Thank you.
Okay, and thank you your question. I think you have your question has included so many topics. I think in Taiwan or in the world, oral scanner is the popular now, because when the oral scanner we can do the database and the transfer file to STL, then 3D printing to print the teeth. But we have the big problem, because today talk is too short. Resolution and precision is very important for the 3D printing machine. Maybe I will talk to you in here. Okay, SLS and the SLM, the precision and the resolution is the best for the full world, but this machine is very, very expensive. And the SLA and the 3DP, maybe I think the precision and the resolution is the second level. FDM is the very rough, because the FDM machine is very cheap. So the FDM, if you use the FDM to produce the teeth, just add as the reference, cannot use putting on the patient mouth. just add as the reference. So if you want to do the real oral scanner and finally you put a teeth product used on the patient, you must use the SLS and the SLM. In Taiwan, we have some dental clinic and the dental laboratory. They have the SLS and the SLM, but I think very few because this machine is very expensive. But use this machine has the good benefit because the resolution and the precision is very good. When you measure tooth, you can compare the resolution for the real teeth. So in Taiwan, I have a suggestion. If you want to in the Indonesia, that you are the dentist, I know. If you want to get a good result, you must use the SLS or SLN in line. But this is very expensive. So in Taiwan, we have some many maybe the 100 dental clinic. They 100 dental clinic. They buy the one machine and let everyone to use this and to share this 100 dental clinic to share this machine charge. This is my answer. Thank you.
Are you satisfied with this answer? Or you have any question again?
I think that's enough. Thank you. Thank you, Professor.
Okay. So everybody, do you have any question? Are there any question?
Someone raise a hand.
Okay.
Sultan.
Sultan Aksa. Okay. Sultan
Okay,
Aksa, can you explain what your question to the professor?
okay, excuse me, Professor Sen. Let me introduce myself. My name is Sultan and I'm a dental student. I'm sorry for returning to first topic. So my question is there any difference in strength between the 3D prints and the conventional one? And for the 3D print cost, is there effective for dental practices? Thank you, Professor.
Thank you. Your question is very good. Also, let me I show in here. I think if you want to learn the 3D printer technology in Indonesia, I think you maybe your university to buy the FDM because FDM is very cheap and very quickly to use, and maybe the precision and the resolution is not good, but the shape is very good. Okay, resolution and the precision, meaning the surface, maybe not good, but the original shape is very good. So maybe sometime in Taiwan, and maybe I talk to you in Taiwan, the FDM, because the Taiwan industry is very good, we can manufacturing the FDM. In Taiwan, we can buy the FDM maybe just 30,000 Taiwan dollars, 30,000 Taiwan dollars. But I think maybe sent to the Indonesia become to more expensive. But FDM is not good resolution and the precision. My suggestion, if you have enough money, maybe you can buy the SLA. But today there are so many types for SLA. Do you have here the DLP or LCD? DLP or LCD also belong to the SLA shape because they use the laser, so the precision and the resolution is better. But finally, if you have the charge, please buy the SLS or SLM. This is the best because they use the metal and the ceramic powder. You know, our teeth is the ceramic, implant is the metal. If you buy this machine, you can manufacturing the real teeth on the real implant for you or for your hospital. This is my answer. Thank you.
Okay. Do you satisfied with the quick answer? Or
Okay.
you maybe have a new
I
one?
think that's enough for me. Thank you, Professor Sen.
Are there any questions from the audience?
Someone raise hand. Please.
Okay.
Who
Who raised your hand? I don't see in here. Who raised the hand? Can you read?
ALFAREGI.
Okay, I will see it here. Okay.
But
There are two participants raised the hand. maybe one by one. If you have any question, you can talk one by one. Who the first? Okay, Iqbal already raised the hand.
Sorry, two people.
Yeah, that's me and Iqbal. So maybe another student have a question. I want to hear from the girl. Who want to talk with Professor Sun? Maybe have a question. Maybe you have some sample, or you maybe want to discuss something. You can raise your hand or only talk in here. Okay, everybody? No one? Okay, Professor, if there are no future questions, we will close today's lecture. Once again, we truly appreciate your time and expertise, Professor Sun, and would like to present you with the certificate as token of our gratitude. Miss Della, can you show Professor Sun the certificate? Miss Della? Miss Della, can you show the certificate? Or Mr. Madan?
Okay.
Okay,
Thank
this
you.
certificate for you, Professor Sun. Thank
Okay.
you very much for your lecture today.
Okay, thank you, Professor Sylvia. And everyone, next year, 2025, I will go to the Indonesia. Maybe there are so many university we are inviting to get a talk. I also want to go to your university. Maybe we can meet each other. Thank you.
Okay, maybe after go to Hasanuddin University, you can continue your move to your trip to the Ulawapan University. I
Okay.
think it's around February. Yes, Professor.
Okay, thank you very much. So
Okay,
I want to
okay.
see you quickly. Thank you. Bye bye.
We look forward to seeing you once again next time.
Okay.
Okay,
Bye bye.
Professor?
Okay.
Okay.
Thank you. Thank you. Bye
Bye-bye.
bye. Bye bye. Bye bye.
Thank you, Professor.